Okay, so thank you for. I think that it's a good introduction to now comment on the technical way that Ergo AI works. Okay, yes. So I'm going to share the presentation now. Okay, here it is. So what I want to introduce is okay. First, what is the IA of Ergo IA? Well, this is because it's in Spanish. You will know it more probably as AI, the artificial intelligence. As a short introduction to why this service works, why the ergonomic assessment can be done mostly automatically thanks to this kind of tools. And then I will go briefly through the characteristics of this service, very briefly, because Mercedes has already introduced some of the main concepts. And then, most importantly, we are going to show a use case of the tool to see how to use it and how to see the results and how to take advantages of this technology. So first, as I said, this IA is what in English would be AI, the artificial intelligence, which everybody has heard about and looks like some kind of magic that computers can do, but it is really not magic. It's just a technology because it's a set of algorithms that can be used by computers to solve problems. The difference with traditional computer programs is that the kind of problems that are solved by artificial intelligence is the kind of problems that humans deal with very intuitively, but are really difficult for not for computers, but for the traditional way of programming computers. So the best way of explaining it is with an explanation of how learning works in humans or animals in general, in nature, and how learning works traditionally with computers. The way that we teach computers to solve a problem is normally by a set of rules, like in this case, okay, let's see how to identify some kind of animal and classify it between foe or friend. We in computers normally write down a set of rules, but this is not how things work in nature. In nature, we learn by examples. We see different kind of items, in this case, animals, and by experience, we learn to distinguish, and we don't analyze the characteristics of their body or whatever. We just learn it by example. And this is the basic idea of neural networks. We give examples, we give answers. In the case of ergonomic analysis, we would give images and we would give their classification as an expert ergonomist would do. But even within this framework of artificial intelligence or neural networks are two ways of doing it. The kind of neural networks that exist since several decades now is the kind of traditional machine learning, where when we have a complex input like images, we first extract some features like the predominant color, the width or height of different sections of or things that are seen in the image, and then after extracting these features according to some rules, like I said, the color, the width and height, whatever, we train the neural network. And this is good, but has a limitation, because the more data we have, the better these tools work. Actually, they need data. Without data, neural networks do not work. But if we have to extract some features to train, we are limited. The performance is limited by the features themselves. But deep learning is the kind of is a different kind of training in which the features themselves are also learned automatically. We don't have to say the computer what kind of features they have to look for. They just find them themselves. And the interesting thing is that the more data we have, the better it works without any kind of limitation. And this is the kind of learning that of machine learning that we use with Ergo IA. Some of the characteristics have already been described by Mercedes before, so I will go very briefly over them. The advantages she already mentioned is that it's not like other tools for automatic detection of postures, because we don't need to put sensors on the worker. We don't need to calibrate the kind of camera. It works with any kind of image. And of course, another advantage is that it is a web app, it is a web service, and this means that you don't need to install anything on your computer. You only need a device with a web browser and internet connection. Also, it's a tool that works in the cloud, so it works anytime, 24 hours, 7 days per week, and it's scalable according to usage. Now we have launched very recently this tool, so in this moment it doesn't need many resources, but the more people are using it, the more resources we can include without any kind of disruption to the service. And then I will go with an example that you will see, but the basic workflow is this. It's very simple. You just have to upload a video from the worker, select a fragment of interest where the conditions are okay to analyze the image, and then everything else is done automatically. All the detection of the person and the detection of the different postures in the methods of assessment is done by the artificial intelligence algorithm. Although, as I will show, the users have the possibility of also tweaking the results or adjusting it or correcting them if the machine has not done it correctly. Okay, so let's go directly to this use case. I will now, I have closed the presentation and I will open the web service and show it directly. Okay, so. Okay, I suppose you can see it now. It's this is the website of Ergo IA. So as I said, it runs in any computer. You just access with your credentials. Okay, this is the Spanish version, so I switch it to English. Login, and then okay, the different sections are besides the homepage, list of the assessments that have been done. In this moment, we have these two examples. You can do a new assessment. I will go now on it. And you also have a help section where you have also some videos where you can find, or you can follow more or less the same kind of a procedure that I am going to show, and also the keys for the correct recording of a video. This is very important, okay, because this is artificial intelligence, so means that it is not natural intelligence, and computers are not as intelligent as people still. So they cannot guess where a person is, they have to see it. So it's important, besides, of course, setting up before recording the scenario, or also plan what are you going to record, to record the video in a way that is appropriate for the machine to find the person and recognize their posture. So for OWASP and REBA, at least, it is important that the entire body of the worker is seen. So also the parts of the body that you have to analyze must be recognizable, and it must be a single worker, because otherwise the machine cannot decide who is the person that could be evaluated, and the result could be confusing. Also, the better is the image of the person, the better will be the results, of course, and this is a very important thing to take into account. So these keys, you can find them in this section, but also we are going to see that you can find them when you do a new assessment. So I will start with a new assessment. The procedure is very easy. First, you have to fill in some details of the workplace, or the worker, of the evaluator that will be used for the report. This is not crucial. The only crucial thing for the analysis is to choose the method, but here maybe any information that you want later on in the report. So I going to use a video of a warehouse, of carry loads, whatever. Okay, choose the company and the date. This is the only required data. And also, to answer this question, if you have the consent of the worker for IBB to use the video processor later on for R&D purposes. This is very important because, as I said before, this technology works by learning from examples. So if you say no, you will do the assessment, but the algorithm will not improve. If you want to help us to improve and get better results later on, it's recommendable that you get the consent that you can obtain from this link. This link is a PDF that you have to have signed by the workers due to privacy issues. And if possible, say yes to help us train the machine. So after you have filled in these details, you just have to add a video and get the fragment that you want to analyze. For this, I will ask you allow me to use a video that we recorded, because if this is done at the same time as transmitting the webinar, the machine, the computer goes a bit slower. So to save some time, I will show this process in a recorded example. But basically, it's the same. So I'm going to show it. Okay. Wait a minute that I set it up. Okay. Okay. So can you see the video? Yeah.
Yes.
Okay, so this is the screen where we were. You just have to select a video from the computer, whatever. We have chosen a realistic video for this example, where you have a person that is carrying some loads from a warehouse. So it can be, as I said before, any kind of video, but sometimes you are recording normally in situations where you don't have, not in all frames, everything of interest. We cannot see the person in all the frames, so we have to look for some fragment where the person can be seen totally, like this. For instance, when we start at minute number 1, well, here in this moment, he's still partially hidden. Here is not, so we can stop here. And for instance, we can choose, let's say, 1 minute starting from this point. So with this, we can select. So it's not necessary to have the video edited beforehand. You can use the service of ErgoIA to make a very simple selection of the fragment that you want to analyze. So if we are satisfied with this, we just then click Cut Video after giving it some name, and we can see how many frames we want to keep. This 1175 is the total number of frames that are in the video in this fragment, and we can choose any other number below this. For very long videos, we could choose up to 3600 frames to make it reasonable, because if otherwise the more frames we select, the slower or the longer will take this process of cutting the video and editing. We have in this example selected 100. It goes, we can see here, about 2-3 frames per second. So in less than 1 minute, the selection will be done. This is the slowest part of the process, but as you can see, it's still a lot of time saving if it just the rest is done automatically. You just so we have already 80, nearly 90, so we are close to the end. Okay, so then this is selected, so we can here replay the segment that we have cut. So we see that we can see the person. In some frames it is a bit blurry, so there may be problems with that, but generally, okay, if we are happy with this, then we just have to send the video and let it process it. So we review it, we are happy with it, we send it. So then after sending it, we have to wait also a brief time. This is a bit briefer while the task is being sent, and then when it ends, it goes directly again, okay, to the initial screen. But the difference you can see is that now there is an associated subtask that we can see the details. We can again review it. We could delete it, and after looking into this, then we could add another fragment of the same video, or if we wanted, we could replace it by another one. So we can either select another fragment, we can click this button to import a new video, and okay, this is the process. Here you could just add other videos and have a task with several subtasks. So now I'm going to show again the complete or the live example. Okay, so that we can see. Okay, so this is how we could make a new assessment, but we can go back to previous assessments. So this is, for instance, the same that or something similar that what we made before. It's not the same, it's an earlier one, but with the same example. We could go again here and then go again to the subtask, add a new subtask again. But the interesting is to see the results. Okay, so after we have done all the recording and uploading the videos, we can see the results. In this case of OWASP, we have the different subtasks that we can browse and navigate through them. And here we can again replay it or go through the different frames with the slider of frame by frame and see this result. That is the automatic classification that has been done by the neural network. So we can see if there is some other point where the person is leaning, for instance here. Okay, here it was turning, leaning, and the point is that this, if I'm not happy with this, because I consider, for instance, that here the person is not yet with the back tilted, and I consider that it is straight, I just click on here, and okay, this is okay. If he's turning, this is automatically recorded so that I can fix the assessment very quickly. I could also say that the load is different. This is not done automatically. This has to be done manually because the artificial intelligence cannot guess if the person is carrying something or not. It's only detecting the posture, and then we can see the results. This is the frequency of risks, of risk number 1, 2, 3, 4, according to this method, and of the different postures for the back, for the arms, and for legs. And this is a graph, a plot with for the different frames that were selected, so that we can see when the risk was higher, and then choose, for instance, here the frame number 56 and see directly what was the posture in at that point. This is an automatic navigation. We can choose here and in there. And these results that I can see here and navigate and also fix are also available as a report. Here, if we go back to assessment, I can see the report where it is downloaded as a PDF. Well, okay, here it is. These are the details that were written first in the form, and then we have the same histogram of results. And if I had different subtasks, I would see all of them in different pages. This is one of the use cases. The other use case is with the REBA method. The interface is the same, the workflow is the same, but the interface is different because, as you may know, REBA is quite more complex. So we have to choose postures for the back, for neck, legs, left and right upper limbs. But more or less it works in the same way. And then we have also different plots for the different parts of the body, left and right as well. And again, we can see in this case, for instance, if we navigate to the worst frame of this, we can see more or less this one, or we can go to other and see what was the posture and also correct everything. And also we can download the report that, as in the case of OWASP, summarizes the information that was recorded and automatically automatically detected or adjusted by the evaluator, but of course with different kind of data, because this is the REBA method. And finally, for people who are using the Ergo IBB software for assessment of REBA, OWASP, and other methods, it's also possible to download a file that will be possible to import into Ergo IBB later on if you want to cross both tools. And okay, I think that this is basically all an overview, a perspective of the tool. So I will give the floor again to you, Mercedes.
Questions?
Okay, yes, we have some questions. The first is the efficiency of the IA system partly depends on the human models functioning implemented. How does this work in your system? Elios, we can hear you. Sorry.
Okay, sorry, I was muted. I don't totally understand what is meant by the human models functioning implemented. If I try to guess, perhaps Bernard can rephrase the question. But if I understand correctly, or I guess correctly, he may be meaning what kind of model of joints, like what we saw in some of the slides. It is not seen in the application, but in the slides we saw some kind of skeleton model of the person. If he refers to that, well, yes, it depends, of course, on how the person is detected. But basically, for the methods that we are implementing, um, the tool, the REBA or the OWASP method, only need a rough estimation of the angles and so on. So it's not needed such precision as it would be needed, for instance, for some kind of biomechanical assessment of gait or whatever. It's just detecting if it is more or less flexed and so on. Of course, different models might give slightly different results for the same posture, but here the limitation, I would say that it's not that much on the kind of internal representation of the person, but rather the quality of the image, as I said, because there will be more difference of between a video where the person is seen correctly or and another video where it's a blurred image and so on, than between the same image and two different kind of models of the person, so to speak.
Okay, Elios, thank you. Another question is, how do the Ergo IA measurements compare to golden standard measurements in lab situations?
Mm-hmm. Yes. We have not compared it with lab measurements, for instance, of a person wearing wearable sensors like inertial measurement units. I know that there are other methods for measuring postures using that kind of sensors in the laboratory, and we have not compared it because our goal is not to obtain a precise measurement of how many degrees is the elbow flexed. Our target is to match the visual estimation of a person, of an evaluator of a task, and do it quicker. So our gold standard is not lab measurements. Our gold standard would be what a person evaluates normally with these methods. And what we try to beat, so to speak, is the time that it needs to do it. Of course, giving as much as possible the same kind of result.
Mm-hmm. And how practical is the Ergo IA with integrating OWASP when the person has to be in full camera view all the time, which is practice is not always feasible?
Mm-hmm. Yeah, this is a limitation. As I said, it's the kind of artificial intelligence that this is using. Well, the artificial intelligence neural network that is implemented does not need that the full person is on the view of the camera. If you have a person where you cannot see the legs because is sitting, for instance, like we are seeing, it will detect the head, it will detect the shoulders. If I was a bit farther, it could detect my arms. But since the OWASP and REBA method are methods to assess the full posture, it will give the result that you will see in the interface is only the result of the parts of the body that are seen. So if you are recording somebody that has the legs hidden by a box or whatever, in the interface that I showed before, you will see that it has detected the posture of the trunk, the posture of the limbs, but the posture of the legs will not be detected. It will be grayed out without any result. And consequently, since they are both REBA and OWASP are methods that need the whole posture, the assessment of that frame will be incomplete. So what it sees, you will see it in the interface, but that part you will have to click it manually if you can guess, for instance, how the legs are.
Okay. Is the raw data from the measurements available for using other ergonomic guidelines, like NEN ISO 11226, for example?
You mean that if you can I'm not sure if I understand. Can you repeat the question?
Yes, and also you can read the question in the chat section.
Okay.
But I can read it again. Is the raw data from the measurements available for using other ergonomic guidelines like NEN ISO?
Now, in this moment, what we have implemented is OWASP and REBA. As Mercedes said before, we are going to implement new methods. Like the next one in our roadmap is the repetitive task method, and later on, depending on the demands of users, there will be other methods. But if the question is if I can reuse the data that has been extracted by the tool to feed it into other method, the answer is no, because the way it works is not by extracting raw data or extracting those features that you can use later on. It directly tries to give an answer to these methods from the image. Of course, if you keep the video and later on we implement other tools, you will be able to again upload that video and make another use with that video and get the result with that new method. But it will be just like opening a new session with the same video.
Okay. How was the software results validated?
We are now beginning with that kind of validations with real experiences. Maybe Mercedes, you can give more details about these experiences.
Yes, of course, as you know, OWASP and REBA methodology is totally validated, and now we are working with different partners making the same evaluation using just Ergo IDD and using Ergo IA, and checking that is the same result, and the ergonomic risk is the same. It's not a very big differences. And we are trying just to validate that our algorithms are correct, because as I said, the methodologies are totally validated, and the neural networks are totally validated. And then, as I said, we are validating just our algorithms.
Mm-hmm. Another question is, I guess that there are some requirements for the making of videos, angles, duration. Is a training necessary? For example, could I use all videos to try the system?
Yes, yeah, they can be used with older videos. Regarding the conditions of the video, they are what I showed before, and when you get into the screen of introducing a video, you have also again a link with those requirements. More than requirements, they are recommendations about the quality of the video to help the artificial intelligence to recognize the person. Regarding the duration, it's not limited. As I said, there is a limit of number of images that you extract from the video that can be analyzed in a single shot, so to speak. That single shot is a subtask within the task, and that limitation is that you are not allowed to submit a subtask with more than 3,600 images. That is really a lot. This limit is set in order to avoid that the time that it takes for processing rises without any kind of limit. 3,600 is really sufficient for most. So if you have, for instance, a video of half an hour where you were just recording and try to submit the whole video, it will limit you to that number, and it will subsample that video until it gets that number. So there is no hard limitation except the number of images that you can submit until the in every subtask. And regarding the angles and other conditions that you might have in older videos, like the quality of the image and so on, well, it's the same for new and older. It's more probably that if you have an older video, the quality might be not as good as with a new video. But if you have an old video where the person is correctly seen, it should work just as well as with one made on purpose for this.
Just to add that Elios showed in his presentation, in the help of Ergo IA, you can see some recommendation about the specifications of the videos.
Okay. How many situations did you implement in your IA?
You mean, for instance, examples of these different tasks, or if the question is about that?
Yes.
Yeah. Okay. So if the question is how many kind of workplaces have been used in training, initially it has been trained in recognition of different well, any kind of posture, not only from workplaces or from the usual workplaces like work office or a warehouse like this, but from general images and videos that we had available from our experience, also freely available videos and so on. Of course, this means that well, our intention is to start to be as general as possible in this training, so that it gives more or less it's not very biased, so that avoid that the results that they give are very biased, for instance, to work offices. But later on, as the machine is trained, it will learn to recognize better the situations that are most frequently used. But in this moment, it's just a generalistic kind of posture recognition.
If no comparison with Golden Standard was made, have you compared it with assessors scoring postures with the normal checklist? And how do they compare?
I think I have answered in my last response to the question.
Okay.
We have count with different partners to make a validation and compare the results using ErgoIA and using other ergonomic risk assessment software.
Mm-hmm. Regarding pricing, is there any price difference for company use versus academic use?
Currently, we don't have a differentiation price. You can see the price in the website, in the landing page, but we have sold to a university in Ecuador, in Latin America, and we have reached an agreement that we need a lot of videos to make the training of neural networks, and they have had a reduced price with the condition that all the videos we can use to train the neural network. And then if you want, you can send an email to ergoia ibb.org and we can talk about it.
Okay. Is in plans to include other methods, such RULA, for example?
As I said, our plan is to include repetitive tasks and a specific methodology that IBB developed some years ago. And before the end of this year, we will implement OCRA. After that, we have to check with our clients what they need, and we will take the decision.
Okay. And if in the selected clip a person is not fully visible, is it then not usable, or does it just measure the body parts that are visible and analyze those?
Mm-hmm. Okay, I will answer this with an example. This is related to a previous question, but I will show, well, it's basically the same example. Yeah, we can see this is a case. Okay, in this case, in this frame, number 21 of the same, this is the REBA method, and this is what the machine detected automatically. So here the person is partially hidden by the boxes here, and we can see that it detected the back that is a bit tilted. It also detected the neck, but well, it couldn't see where is the left arm. Okay, it could detect the right one, and the legs, well, they are partially hidden, and it did not detect them. So this is more or less what I said. By the way, this is something that I forgot to say. In the current implementation of the network, it is not detecting the wrists. So by default, it always leaves wrists without flexion or extension. This has to be changed manually always, but this will be improved in the next version by summertime, more or less, when we will have a network that is able to recognize the wrist. But let aside, this is the situation that I think that the person was asking about. So as you see, the partial recognition is there. So, but the problem is that since I cannot see the whole thing, the assessment is incomplete because the REBA method needs all the data to give an answer. But if I say that I can guess that it's this person is in, well, it's working, okay, and then I cannot see the arm, but I say that the arm is, well, it's not it's less flexed than 60 degrees. Okay, then this is complete, and I already have this risk assessment in this moment. So this is how it works. If it doesn't have all the information, it will only give you the information that it has, basically.
Okay, and the last question is, you have to make a link between the gestures and the risks regarding the anatomy?
a link between
gestures and risk.
Gestures and risk. This is the risk is assessed from the gestures directly using the method. I don't know if this was the question. I mean, we did not invent a new way of measuring risk according to the gestures. It's just taking the poses and applying the OWASP and REBA methods.
Okay, we have another question. This is the last short.
Yeah.
How safe are the videos that are downloaded with regard to GDPR guidelines? Elios, I can hear you. Mercedes and Elios. Okay.
Yes, Mercedes can ask. We already saw. Oh, sorry.
I don't know exactly the legal aspects because a lawyer is working together with us. She's in charge of all these aspects. But if you want to say something about the...
Yes. Okay. Yeah. As you saw when you upload the video, you have to answer this to this form, the form that the person has to fill in. The evaluator has been revised by this lawyer that has been consulted for this, and so according to this is written, or this is made with this expert lawyer that assured that the conditions are according to GDPR. So if you say no, the video will be only used for completing this task of assessment, just as if you used any other way or any other tool to evaluate the workplace that required recording a video. The videos are stored in the cloud, but in a service in Amazon Web Services that are GDPR compliant, and of course all the procedures have been set up in order to comply with this. The condition is the security conditions are the same for videos that you have said yes, but they are marked in such a way that they are available not only for the user that is making the ergonomic assessment, but also for research, but with the informed consent as is explained in the form. I don't know, Mercedes, if you want to add anything more about this.
Okay, thank you, Mercedes. Thank you, Elios. We have arrived at the end of the session. We appreciate your participation in this webinar, and we hope you enjoy it. Thank you very much. We will send you the recording of this session. And thank you again. Have a nice day.
Okay.
Bye bye.
Thank you very much. Bye bye.
Thank you.